Hello, this is Robert Casey, and welcome to Y-SNPs, Key to the Future. This is a part of genetic analysis that a lot of genealogists may not be aware of. Y-SNPs are a very powerful tool for genealogists, and over time, in the near future, will become even more important. This page summarizes this presentation and the benefits of Y-SNPs. The first potential use of Y-SNPs most people may be aware of. It's used for sorting out STR submissions and surname projects under FDA, surname projects. And Y-SNPs are used in combination with Y-STRs to break up groupings of individuals that have potential to be related. The second aspect of Y-SNPs, which is probably not well known, is determining false hits for Y-star matches due to convergence. Convergence is where you do have a match, but because of the age of different Y-SNPs or Y-SNPs not matching, these are really false hits. The Y-STRs are kind of like water flowing down a river. Sometimes they go out to the edge and go to unique values, but a lot of times they flow back in the middle where the marker values were the same when they start out much longer ago. A third thing is developing Y-STR fingerprints. People who are familiar with haplogroup research are very familiar with fingerprints and signatures. This is a really powerful tool for Y-SNP and YDNA analysis in general. Y-STR fingerprints can also be used for Y-SNP prediction, which can dramatically reduce overall testing costs for Y-SNPs, which is a big economic issue. Y-SNPs, Y-STRs, and surnames make a powerful combination. You can use these three major sources of information to evaluate how much the possibility of NPV connections are valid or not. Also, you can actually develop descendancy charts, much like descendancy charts in genealogy, based on all three. There's a very extremely bright future for Y-DNA testing in general. The full genomes, full Y chromosome test are averaging one SNP being discovered per 90 years. That's every 3 generations. You combine that with 400 to 500 Y-STRs that will become available over time, and you'll have the potential to assign unique Y-DNA fingerprints to most of our ancestors in our pedigree charts. Y-SNPs are extensively used for groupings of Y-STR submissions within surname projects under FDA databases. Most projects have groupings of more recent Y-SNPs. If it's a large common surname, there may be a lot of these. If they are clan-based, there are probably fewer of them because there'll be fewer origins for the surname creation. Two largest clusters in the Casey projects are RL226, and these are possibly genetically related, as an example. Most projects also have a lot of submissions just lumped together with a predicted Y-SNP. They're just too old for accurate groupings. But since the Y-SNPs have not been tested, that's the best grouping that can be made. Therefore, you'll see large groupings of kind of catch-all groupings that are not truly related, but with the information provided, that's the best that can be done. Also, most projects have a lot of smaller groups for less common SNPs for the project. These are not really sources from other parts of the world, like a lot of people believe. They're generally minority SNPs for the area, such as Ireland. E, I, and J are very small minority group Y-SNPs that will regularly find submissions belonging to them. In the Casey project, there are two very large RL226 clusters. These may be related, but it's not real certain if they are related. They're both L226, which means they have a common ancestor around 14 to 1500 years ago, but they're distinct enough clusters to track separately from each other. The first cluster has two unique values that are mutated away from the L226 modal, which identifies this cluster from other surname clusters, of which there are about 20 or so identified to date under L226. The second cluster, marked in gray, is a South Carolina cluster. These are cases that have ties back to South Carolina. This is a very genetically isolated branch of L226, and there are a lot of interest and a lot of descendants of this particular branch, and this is also the group that includes my submission as well. This chart shows the very old RM269 submissions, which is around 75% of English-speaking people, or people that actually have English-speaking origins, such as United Kingdom and Ireland. The first grouping in blue shows the ones that have not tested for more recent SNPs. This is kind of a catch-all area. These people share a common ancestor 4,000 or 5,000 years ago, but that's not recent enough to have a significant genealogical impact. Then the green one is one that when I looked at the admin page for this person, all these close matches were RU106, so it could be inferred that this person probably would test positive for U106 as well. The yellow one is another L21 DF13 positive, but it's L226 negative, unlike the other larger clusters. So this is another unique grouping. Another one in the bluish green color is tested positive for DF27 and SR2627. This is a cousin of L21 and also breaks up another cluster. These SNPs are the SR2627 is probably 2,000 or 3,000 years old. So this breaks apart more out of the M269 grouping. The next one is M222, which is another L21 SNP. This is a very large recent SNP mutation, and so this is a very good match for genealogical purposes. The last pink type is 4 submissions that have extremely common marker values with no known Y-SNPs tested, but since they all track each other so closely, they can be grouped together solely based on Y-STRs. This chart summarizes all the other KC submissions that have non-R1b haplogroups. R1b is probably at least 80% of all Ireland, but there are other haplogroups such as I due to Viking incursions into Ireland, and as well just minority SNPs. Many people will look at these and think that they have either Middle Eastern or African origins. That's probably the original origins, 5,000 to 10,000 years ago, but these really should be considered as minority SNPs for Irish groupings. The E cluster has 3 people from the same group and actually has been tested. You have one tested I1 group, which is not very recent, and you also have a J2, which has been tested through the old deep clad test, but J2 is not a very recent SNP because this test was done obviously quite some time ago. This slide introduces a real important aspect of Y-STR matches. There are a lot of false hits even at 67 markers. This is due to a phenomenon called convergence. This is a scenario where Y-STR markers overlap with non-related submissions, and to the more simplistic matching system of FDNA, they show up as matches, but if you actually test the Y-SNPs, you can find out that they're actually, it would be impossible for them to be related. This doesn't occur a whole bunch. It's probably only 5 or 10% of the time. And people are saying, well, that's not very much. But if you have convergence within your group, it could be 20 to 90% of your particular group. So it's real important to determine if you have convergence in your with your matches. One scenario that causes convergence is if your Y-STR markers are very common values. In other words, over time, they've changed, but they've flown back in like in a river to the same area that they start out with. There are ways to test the commonality of Y-STR marker values, and if you have very common Y-STR marker values, you can have matches, but not share Y-SNPs that are 4,000 or 5,000 years old. Another scenario is outlier submissions, or those who we think should test positives but don't. And these are very small groups, sometimes very large groups, of overlapping haplogroups that just migrate into the same patterns. And so that for the outlier submission themselves, all the close matches will test positive for the SNP, but since it's tested negative, it's going to probably have a 90% false hit rate. So this is a real important phenomenon if you're being told that your submission is an outlier to a group. Also, smaller SNP scopes are not always genetically isolated and can't be predicted as well. And when they're not genetically isolated, you can get easily, 30, 40, 50, 60, even 80% false hits. And this is where some more recent Y-SNPs really help determine true matches. This report is a FTDNA admin report, which I looked at one particular Casey submission in the Casey project, and it displays all the matches. And if you look on the very left-hand column, it shows it starting out with a genetic distance of 4, then 5, 6, and 7. And according to family tree DNA, these are genealogically significant because at 67 markers, all submissions with 7 or few mutations are considered potentially genealogically significant. However, this particular grouping of submissions have very common Y-STR values. And because they have common Y-STR values, this is the first scenario we talked about earlier, where because of the common marker values, they can have very different Y-SNPs. If you look at the next to last column, you'll see the terminal SNP. There are 2 additional submissions that are SRY2627, so those could be potentially matches. But there are also 2 L21s and 2 L48s. These are all several thousand years old, so obviously anybody in this particular grouping should be highly encouraged to test their SNPs to see which grouping that they really fall into. Here's a real interesting example of an outlier in the SNP RM222. This is a very large, very recent SNP that has over 1,000 people that are predicted to test positive at 67 markers. However, there is one person, it's a Leicester surname, that we thought for sure would test positive, but it actually turned out to test negative. And so if you look at all the 4, 5, and 6 matches on this page, they all test positive at 1,500 years ago for M222, but the Y-STR person himself is not M222, so they can't have a common ancestor at least 1,500 to 2,000 years ago. So in this situation, for the Y-STR submission, 90% of his matches are going to be false hits. And then for all these others who test positive, it's only going to be a 5% match, a false hit, because the Y-STR is not actually related. This shows the true power of some more recent or younger Y-SNPs. In this case, this is L743, which is under L21, which is, and as you can see, the green ones are all testing positive for L273, and they're all Templetons. This is a scenario where we thought at first that you had to be tested positive for Templetons, but then we look at further matches, and these three pink ones tested negative, but the green one down here tested positive. And it's at 7 mutations away. So it should have tested positive, but these three are at 5 and 6, and they're testing negative. And what causes this is, if you notice, there's a trend here on marker 458. At 16, all the template submissions have 16, which is highlighted in purple. And the only other one to test lower is also purple. All the three that are have tested negative are not 16. So it looks like in order to test positive for L743, you also really need to test 458 equals 16. Now, so the best candidates to test would be the ones here in purple on the left under in the column where they're red and green, because those purple ones all have 16, and they have a much higher probability to be consistent with the other submissions that tested positive. So this is a scenario where all the higher matches match, but then you start getting way above 50%, probably more like 75% are false hits. And so this is the power of recent SNPs to filter out some of the SNPs, some of the matches that aren't really matches. The next real positive thing that can be done with Y-SNPs is to help you determine fingerprints. A lot of people doing haplogroup research are extremely familiar with fingerprints and signatures. These are basically patterns of mutations that you look for common mutations versus how many differences there are between the marker values. The way it works is you take the modal of a broad SNP like L21 or DF27, and these are SNPs that are several thousand years old, and the modal is nothing but the most common marker value. Sometimes it's very clear, it's 70-80%, but sometimes it's in the gray area and maybe only 55 or 60%. So what you do first is you determine the modal of your older SNP, and then you determine the modal value of your terminal SNP. And that's the most common values of the Y-STR markers for your more recent SNP. And the mutational differences between those two is the fingerprint of your terminal SNP. So if you're looking for matches and your terminal SNP is pretty recent, that's a pretty good search criteria. The next level down is you take the modal between the SNP and compare it to the modal of your surname cluster. Now your surname cluster is if everybody that has the same surname that has the same SNP. And so you compare those two, the difference between the most common value of your Y-SNP to the most common values of your surname cluster, and that gives you a very powerful mutational differences between those two identify the unique mutations that make your particular surname different from other surnames that are fairly close matches. Finding close genetic matches is great, and that's a good start, but matches with shared Y-STR margins are much better matches. So that's 2 criteria instead of just 1. And the Y-STR mutations are a much stronger criteria for matching than just raw genetic difference between 2 submissions. Also, finding close matches, similar surnames, and shared mutations is the most reliable way to determine the degree of relatedness between 2 genetic submissions. Fingerprints, which are just the shared mutations among common people, provides more genetic information to analyze your genetic connections. Here's an example of a couple of cluster fingerprints. The first one is the cluster that I belong to, and Casey's that have heritage back to South Carolina. These Casey are also primarily Protestants, which is unusual for a Casey for an Irish type name. So, and they are also in South Carolina in the mid to late 1700s, which is a pretty unusual immigration to South Carolina for Irish people. If you notice this one, where all the pink color is, there's 7 common mutations. This really sets this this genetic surname cluster apart from many others, because L226 is only about 1,500 years old. So here you have 7 mutations set apart from something that's 1,400 years old. So this is a real powerful combination. In fact, we originally had one MPE event, which we quickly determined had to be a Casey male that got adopted. And recently we've discovered a second one. And because this fingerprint is so unique, almost anybody who tests with this fingerprint is probably going to be related in the last 300-400 years, which is a pretty recent time frame. There's a second Casey cluster, which everybody's wondering, what's the relationship between this cluster and the South Carolina cluster. They both are our L226, and they both are they share one mutation from L226 is 534, and the 534 is the only these 2 Casey clusters are the only 2 surname clusters out of about 20 that have that mutation. So there is some support that the 2 that particular marker could have been prior to the surname creation of Casey, and that these 2 clusters could actually be related. But since there's only 1 shared mutation at 1,400 years, that's maybe stretching it. Another thing that had bothered a lot of people is, if you look at 460 in the South Carolina cluster, half of them are 12 and half of them are 13. And that is really great because it divides the whole cluster into one big early branch. But the dilemma was, what came first, 12 or 13? If you look at it as a standalone point of view, you don't know which came first, 12 or 13. It could be, since Y mutations could go either directions. However, since L226 is 11 to start out with, it's much more likely that the original Casey in this cluster was 12, and 13s represent a very early branch that half the Caseys have and half do not. Also, one of the powerful things you can do once you have a fingerprint established is you can sort submissions and look for common matches. In this case, I sorted for the second cluster, Casey cluster here, and found everybody that had these 2 matches. And lo and behold, if you look at all the aqua, there is an exact match between this Casey and this particular Reeves submission. And also it does match a second Casey as well. So since they match so many off-modal markers, the Reeves has a high potential to be an MP event of this particular KC cluster. This chart is showing surname clusters that have been discovered to date under L226. This is just an alphabetical sorting of clusters. First, you have the Bryan, they have 3 common markers. The Butler, which has 3 common markers. These are all pretty good fingerprints. So everybody that has the Butler surname, but not always, but the vast majority of the Butlers have this fingerprint. And so if you have a Butler surname and these 3 markers, you know you're much more closely related. And if you notice all the green, which means you're mutation up, and the browns, which is a mutation down, that's kind of like a shotgun. It just randomly shows up. So those are probably more recent mutations. And since there's no pattern developing, those are probably not that genealogically significant. Now, if you look at the Crow submission, it has 2 markers, but it has a real interesting third one. It has at 391 in the green area 12s, where the last 3 values are 11s. Now, there's 2 scenarios where this can happen. One scenario is that it start out as 11, and then after the surname creation, a big chunk of them, 2/3 of them, had a mutation to 12. Or it could have started out as 12 and had a backward mutation back to 11. Only bigger collections of data and more markers will tell over time which is the case. Testing Y-SNPs can be quite expensive, so you can take broad tests for a couple $100. You can take ones to discover for $1,200, or you can individually test 1 out of thousands for $40 each. And this kind of testing really consumes a lot of valuable resources. So there's a big push by the genetic community to assist this by a form of prediction. Under L221, I have a tool called the L21 SNP predictor, which works for about 50% of all L21. And this represents 40% of all people that speak English today. So that means 20% of all the English people that speak English today, or have origins that spoke English, they can be actually predicted to a more recent SNP, and you can test just that one SNP directly. So around 50% of these younger SNPs are about 1,500 years old, and they're statistically predictable through binary logistic regression. Another 25% are older Y-SNPs. They just have too many fingerprints to be predictable or to be reliably predictable. And also for the unlucky ones that are just hanging out there, there's also 25% that just aren't assigned to any large subdivision of L21. And so what is happening over time, though, is the percentage of predictable submissions will continue to grow because predictable ones are under 1,500 years. And as we discover more and more of them, that means that percentage will continue to climb. Also, as we find newer, older ones, the people who are left stranded will continue to decline as well as more SNPs are discovered. Eventually, almost all the Y-STR submissions will have predictable Y-SNPs as thousands of private and near-private SNPs are found. So we'll eventually be able to predict, well over 90% of all submissions just based on Y-STR markers in the future. This is just to briefly show you how SNP prediction works. This M222 is a extremely broad SNP, but a very recent SNP. Over 1,000 people, or maybe 1,500 people, should test positive for this that have already tested that 67 markers. This curve shows with one outlier. This is one person who we thought for sure would test positive, and he was a pretty high fingerprint match, but he tested negative. And this is the kind of curve you get where at the bottom, the first 4 or 5 SNPs, you test negative universally, the fact that 1, 2, and 3. there's thousands and thousands of people testing negative. But then when you get up to 8, 9, 10, 11, they're over 95%. This particular grouping through statistical analysis has a 99.5% accuracy, which is quite high, and is extremely useful for genealogists to save taking a $200 test and replace it with a $40 test. Before we found this outlier, we really had a much simpler scenario. Basically, everyone had tested that matched 5 markers or less always tested negative. And then everybody had tested at 6 through 11 all tested positive. We're talking about hundreds here. And it had a 99% accuracy because there was only one that was an exception. And it was right on the borderline of, I can't remember, 1 6 tested negative or 1 5 tested positive. But this is what most of the SNPs look like, where you have an extremely well-defined boundary. And so SNP prediction is a very powerful tool that can save a lot of money. Younger SNPs, and these are the ones that are 1,500 years or less, can really enhance the analysis of Y-DNA connections. Many times you can use younger SNPs combined with the surnames as well as Y-STR patterns, and it really helps narrow down potential MPE connections that just genetic distance alone just doesn't do as well. Y-SNP testing combined with Y-STR testing can provide a lot more information to determine a relationship, because now you have 2 important characteristics. You can actually start developing descendant charts, just like genealogy descendant charts based on SNPs and Y-STR mutations that can be really revealing on how the evolution of the branch progressed over time. Here are the first few years of more recent younger SNPs under L21. And if you notice some trends, there's some real interesting information that falls out of this. The first is, if you look at L144, K. Now, K is one of the 2 fingerprints associated with L144. About 90% of them, that's 9 out of 10, are Kendalls. And there's 1 white. So since there's only 10 people out of about 25,000 people have tested positive for these, the white, has a higher probability of being an MPE of the Kendall line. The same way with the Whalens and the Bracewells or Braswells and the Mary spelling variations of these 2 surnames. These probably this particular SNP mutation probably occurred right before these surname creations, or there may have been a very early name change of these people to where one kept one surname. Whalen is probably more likely because there's twice as many, but it could be Bracewell as well. Then you get very small SNPs like 580 on the very bottom here. 2 of them, and one's Norris and one's Walters, and only 2 people out of 25,000 have tested positive for these. So obviously, since only 2 people have tested positive, that implies that there could be some kind of MPE relationship between Norris and Walters for these 2 particular branches of these surnames. Here's an example of a little more in-depth study of a SNP L371, which is another SNP underneath L21. It has around 70 submissions that are 67 markers that are predicted to be L371 positive. 29 of these have the Q surname, which is 41%. Now, this may be due because Pew is a very well-tested surname, but you can break it down further. Not only L371, if you have the marker value of 413B less than 22, that includes every Pew submission, plus 3 others without the Pew surname. So combined with L371 and this particular mutation, 91% of Pews. Two of these surnames were Harry and Hayden's, so these are probably pretty good MPE candidates for pews. And the third surname was listed as has not been recorded yet, so it's unknown. So the mutation 41323 to 22 is a post L371 mutation. What this means is that L371 mutation happened first, and then the Y-STR mutation 23 to 22 happened probably 100 to 300 years after the L371 mutation. And it is very near this 413 is very near the time when people started taking on the Pew surname. Now, another interesting twist is there's 4 West submissions that have tested positive for 371, and they are believed to be Pew MPEs. But these 4 submissions do not have the typical 413 the 22 mutation. So there's, this is kind of a yellow flag for this particular scenario, because they thought they were, there's a common belief that these are MPE mutations, but this would require, if they really are a Pew, then they would have 22. To get back to 23, it had to be a backwards mutation, which is possible. Or this West could be a very early branch of Pews, and we just haven't tested all the Pews yet, and it could have been right before the Pew surname was created. Or it may not be a Pew MPE as believed because of this. It's inconsistent with the most common scenario for this mutation. Here is a chart that tries to sort out all the Casey branches that are under L226. And this is kind of an older chart that shows the most likely scenario of how 3 potential Casey clusters happened. First, you have the L226 creation around 700 AD. And then off to the right, you have a lot of the Irish names, Brown, Bryan, Bryant, Butlers, Crows, Harts. These all have different off-modal fingerprints than 534 to 14. Only the 2 Casey clusters down below share that. So the next mutation to get down to the common group for all 3 clusters was this first mutation. Then if you go down to the Munster Casey, around 1300 is when this one probably happened. There's one additional mutation. Munster is in southwest, it's the southwestern part of Ireland, around County Cork. All these people either currently live in that area, or they have known ties back to that area. Now, not all Munster Caseys belong to this group, but more than half do. Then you have another 3 mutations in common to the next common set between 2 other clusters. And then you have 4 more mutations to get down to the fingerprint for the South Carolina cluster. But by doing a Y search for the fingerprints of the South Carolina, I found a very interesting Oxford ancestors test. It's not a very high resolution test. I think it was like 23 markers, but it had these 3 markers, which are very unusual markers, and it looks like it matches L226. So we speculate that that this is a branch of the early branch off of the Caseys that probably moved to England, changed their surname to Kersey, which is not really a common Casey derivative. It's more of an English name. And they probably anglicized their name to Kersey to be more acceptable to the English culture. And this happened around 1500. And this makes an interesting proposal of trying to run down this branch and finding yet a third cluster. There's also some kerseys in South Carolina that could be related to this group. So we need to start testing those submissions and see if they match this kersey fingerprint. Here is a genetic tree of the Munster, Ireland cluster. As you can see, I won't go into all the details, but there's some very strong branches. This branch 1, which is off to the right, has one strong mutation that nobody else has, and then another sub branch has 3 more strong mutations, and has 3 different submissions underneath it that are not too far genetically apart. And so this is what you can do with Y-SNPs and surnames and Y-STR mutations, is develop descendant charts. Now these can change over time because these all these markers, they can mutate back and forth. So this is just the most likely statistically probable descendant chart at this point in time, not a guaranteed descendant chart of relationships. And there's a whole bunch of generations missing in this chart as well, of course. The next year can be seen a real explosion in growth of SNPs due to full Y chromosome scans are being done today. Just under L21, there are 25 pending full Y chromosome tests, and it is expected to find 30 new ones for each test. That will cause a growth in the next few months from 150 total SNPs under R21 to 900 or more. So that's just a tremendous growth in information to analyze. They are discovering, on the average for the first dozen tests, every 3 generations or about 90 years, there's a new SNP for every branch being tested. Now, over time, because people with common ancestors start testing, there won't be 90 years on the more older legs to generate. So the number of SNPs per test will go down over time. There's anticipation that there could be as many as 10,000, which we have today, well up to 100,000 or maybe even many, many more. And so this 100,000 divisions of mankind is getting a lot of granularity. And since it's every 90 years, that means your great-grandfather, every great-grandfather on the average will have a new SNP. And then when you combine 500 up to 500 YSTRs, you'll be able to assign unique YDNA fingerprints to most of our ancestors on our ancestor charts eventually. Now this will require a lot more tests of individual people to make these assigned, but the power of YDNA is just unbelievably powerful in the future. This chart shows you SNP discovery under L21. As you notice, from 2006 to 2009, it's basically flat, and then 2009 to 10, they just started discovering a few SNPs, and then in the last 3 years, it's been a steady pace of rapid growth, but not really rapid, and our manual methods have kept up with it. And these are based on the ISOG tree. The ISOG tree has to be 7 mutations apart, and so all the private SNPs and duplicate SNPs aren't counted. If you add the private SNPs that are currently known, it doubles it from 55 to around 110. And if you add all the duplicate SNPs, which are ones that track existing SNPs, as well as some of the recurrent SNPs that have multiple mutations of SNPs, which is less desirable for trees, but genealogically could be important. You almost triple the number of SNPs. The full Y chromosome test is returning incredible numbers of new SNP mutations. The previous SNP discovery test was family tree DNA's Walk the Y, which only scanned 600,000 base pairs, which out of 58 million base pairs, that's a very small amount. The full genomes is testing around 14 million. This is a 20-fold increase of what was being tested. So that means we're going to find 20 times, 15 or 20 times as many SNPs as we have in the past for about the same price as we did last year. And this is probably 95% of all possible Y-SNPs with this test. So the future is here. Due to the read length and some areas that are very repetitive, it won't quite catch all the Y-SNPs because some areas are very repetitive and take much longer read lengths to catch some of those in the repetitive areas. But it's probably, the vast majority. There are 58 million base pairs in the Y chromosome, but there are large areas where there's just not any variation at all. It's not very rich in mutations. And there's other areas where it actually recombines with the X chromosome and is recombinational in nature, so it changes dramatically every generation. There's some challenges with these tests. The analysis time for this huge influx of Y-SNPs, the tools, the databases. This is coming from a new company. It could be bottlenecks to research these new SNPs. Also, the source of testing these individual SNPs, especially the private ones, will be challenging. We're going to have to find a source of how to test these. Testing one at a time is going to be expensive, and it's probably not very economical for the companies testing them as well, since there would be so few people testing them. And so we have to work out those details over the next year or two. I hope this has been useful to you. If you have any comments, drop me an email through my website, and hope you enjoyed this presentation.